Hello, welcome to my channel. In this video, I'll be discussing the mole concept in chemistry, which is an important topic in JAMB UTME syllabus. Mole is fundamental concept in chemistry and it serves as a bridge between molecular scale and the macroscopic scale. It allows chemists to count atoms, molecules, and ions by weighing them, and it's very important for you to understand the mole concept as you'll be using it a lot in doing a lot of calculation in chemistry. What is mole? On a general note, general language, there are some terms that we use that connotes quantity. For example, if someone say dozen, we know that person is talking of 12 or multiple of 12. If someone says car, we know that person is talking of 20 or multiple of 20. The same way, when you say mole in chemistry, it connotes quantity of something. And that has to do with the quantity of the particles that make up the matter in question. For example, if we are talking of elements, atom are the particles that make up the elements. And when we are talking of compound, molecules are the particles that make up compounds. So when you say mole of any of this, it means the quantity that contains 6.022 times 10 raised to power 23 particles of that substance. Meaning that when you are talking of element, when you say 1 mole of an element, it means the quantity of that element that contains 6.022 times 10 raised to power 23 atom of that element. And when you are talking of compound, it's when you talk of 1 mole of a compound, it means the quantity that contains 6.022 times 10 raised to power 23 molecules of that compound. That is what mole is. And that is what this definition is talking about. That the mole is defined as the amount of substance that contains the same number of entities as there are atoms in 12 grams of pure carbon 12. Mole is usually calculated as mass over molar mass. So 1 gram of carbon divided by molar mass of carbon, 12 gram of carbon divided by molar mass of carbon will give you 1. So the quantity, the amount of substance that contain the particles that is contained by carbon 12 gram of carbon 12 is 1 mole. So that's just what this definition is talking about. Now this 6.022 that I kept on repeating is what is known as the Avogadro's number. Okay. Why do we talk of mole concepts? It's simple. It helps us in doing, it simplifies a lot of calculations for us in chemistry, as it is difficult for us to count the number of particles of a matter, be it atoms or molecules. All those things cannot be counted. So moles simplify the calculation for us. What is molar mass? Molar mass means mass of 1 mole of a substance. Okay, and it is expressed as gram, that's the weight, per mole of that particular substance. And if you want to calculate molar mass of a substance, you need to get the chemical formula of that substance. Then use the relative atomic mass of each of the elements that make up that substance. Multiply by the mole of the atom in that substance. For example, here now, we have hydrogen times 2 plus sulfur times 1. The 1 is there, it's just not written there. Plus oxygen times 4. What's the relative atomic mass of hydrogen is 1 times 2 plus what's the relative atomic mass of sulfur? That's 32 times 1 plus what's the relative atomic mass of oxygen is 16 times 4. So when you add this together, it will give you the molar mass of H2SO4. Now, we'll be talking about the different applications in which we use mole in chemistry. And one of them is when we want to convert mass to mole. You can be given the mass of a compound and you'll be asked to calculate the mole. The formula to use is mole is equals to mass over molar mass. This formula is very, very important and you need to take note of it. So to get the mole of this 36 gram of water, it will be equals to 36, which is the mass, over molar mass of water. The molar mass of water is 1 times 2, which is the relative atomic mass of hydrogen times 2 plus oxygen. Relative atomic mass of oxygen is 16, which is equals to 18, right? So over molar mass here, and this will give you here 1, here 2. 2 mole. The unit of mole is mol, mole. Take note of the spelling. Mole is a quantity, right? And mole is the unit, mol. Another calculation in which you can use mole is when you want to calculate the number of particles contained in a quantity of a substance. And the way you calculate it, the relationship is number of particles, be it atoms or molecule, is equals to the mole of that substance times 6.022 times 10 raised to power 23, which I call the Avogadro's constant the other time. Okay, so the number of particles for this 2 mole of water is 2 times 6.022 times 10 raised to power 23, which is equals to 12.044 times 10 raised to power 23 particles. Okay, in this case, it will be molecules. Okay, so also you may be given mass sometimes and you'll be asked to calculate the number of particles. What you need to do is you need to calculate the mole of the mass that you are given. Okay, and you know mole is mass over molar mass. So after you got the mole, you just multiply it by Avogadro's constant 6.022 times 10 raised to power 23 that we have been using. You get the number of particles. You can also sometimes, if you want to calculate the volume of a gas at standard temperature and pressure, you may need to get the mole of you may be given the mole of a gas at standard temperature and pressure, and you'll be asked to calculate the volume of that gas. And um, from the ideal gas equation, PV is equals to nRT. You can watch my video on kinetic theory of matter and gas laws. You come across this equation. It is from this equation that we know that at standard temperature and pressure, standard pressure is 1. If you replace it in this equation, let's say P is 1 times you want to know the volume of gas at standard temperature and pressure is equals to, let's say we want to know the volume of 1 mole of a gas, N will be equals to 1. This N is mole times this R is what is called gas constant, is 0.082, okay, times temperature in Kelvin, 273. The standard temperature is 0 degrees Celsius, and you need to convert this to Kelvin by adding 273 to it. It will give you 273 Kelvin, okay, and that is what is here. Now, volume will be equals to 1 times 0.082 times 273. This, if you calculate it, it will give you 22.4 liters or 22.4 dmq, which is the same. Okay, so it means 1 mole of a gas at standard temperature and pressure usually have volume of 22.4. So you may be given the mole of a gas and you'll be asked to calculate volume. All you need to do is volume is equals to the number of mole times 22.4 liters. And in this case, is 3 mole times 22.4, which is equals to what? If you do the calculation here, you will get the that's around 67.2 liters. That's the volume of this oxygen, 3 moles of oxygen at standard temperature and pressure. So that's how you'll be calculating the volume of a gas at standard temperature and pressure if you are given the mole of the gas. We also use mole in calculation of the concentration in solution. Concentration, concentration is equals to mole over the volume of the substance. Okay, so and this is expressed in 1 molar. 1 molar is equivalent is what the 1 molar means is 1 mole per liter. Okay, that's what it means, and it can also be 1 mole per 1000 ml. Take note of this. So anywhere you see 1 molar, it means this. Okay, so you may be asked to calculate the mass of a substance that will help you to prepare a particular concentration of it, of the solution of that solute. Like in this case now, they ask what mass of sodium chloride is used to prepare a 1 molar solution of sodium chloride. What it means is how many, what's the mass that you use to prepare 1 mole per liter, meaning that's 1 mole in 1 liter. So what we need to do is to calculate the mass using the equation mole is mass over molar mass. You see, this formula is very famous and you need to know it, okay? Over molar mass. To get the mass, it will be equals to mole times molar mass, okay? If we replace this 1 mole in the equation, it will be equals to 1 mole times the molar mass. What's the molar mass of sodium chloride? That's 23 plus 30, hope 23 plus 35.5. Hope you know this is the relative atomic mass of sodium and this is the relative atomic mass of chloride. Okay, and this is equals to 58.5. So times 58.5. So the mass that will be required will be equals to 58.5 gram of sodium chloride will have to be dissolved in 1 liter to give 1 molar solution of sodium chloride. Okay, so this is how you'll be calculating the concentration using the mole, or you may be asked to calculate the mass of the substance that you will need to form that concentration. Okay, now also in dilution formula, dilution is about adding water to a solution to make it up to a concentration. That is dilution. And when you are adding water into a solution, you know that the mole of the solute that is dissolved in that solvent is not changing. So from our formula where we say concentration is equals to mole over volume, meaning when we add water to it, it means the mole will be constant, right? Meaning that concentration times volume, initial concentration times initial volume will be equals to final concentration times final volume. Okay, so this is the dilution formula. C1V1 is equals to C2V2, and that's what you will be using in when you need to do calculation for dilution. It's how much water is needed to dilute 50 ml of 2 molar solution of hydrochloric acid to 0.5 using the formula C1V1 is equals to C2V2. The initial concentration is 2 molar times initial volume is 50 ml, right? Is equals to the final concentration that we want to get, which is 0.5 molar times the volume, which will be the final volume. So the volume V2 will be equals to 2 times 50 divided by 0.5, which will be equals to 200 mils. Meaning that the final volume of the solution will be 200 mils. And we already have 50 mils in it. Meaning that if we subtract the 50 mils that we already had, it will mean we will need 150 ml of water to be added to that solution to make it up to this concentration. Okay, so because what was asked is how much water is needed. Okay, they will not say, they didn't ask for what is the final volume of the solution. So take note of that. The gas laws and the mole. Um, you know, this gas law, this ideal gas equation is very important for you, and that's why it's very important for you to watch the video that I did on kinetic theory of matter and gas laws. You understand this equation is equals to nRT. You see, this formula is the ideal gas equation, okay? And according to the ideal gas equation that I explained earlier, at standard temperature and pressure, 1 mole of a gas occupies 22.4 liters, right? So that's the relationship between the mole and the volume of a gas. Okay, sometimes you may be given the mole of a gas and you'll be asked to calculate the volume at standard temperature and pressure. So all you need to do is the volume will be equals to the mole times 22.4 liters. Okay, at standard temperature and pressure. Okay. Now, having gone through all these concepts, the mole concepts, let us answer some questions for us to test our knowledge and understanding on the lesson that we have had. We'll start with this question number one. It said, what is the number of atoms in zero point 0.5 moles of oxygen gas? The number of atom, which is the number of particle, is equals to the mole times Avogadro's constant, 6.022 times 10 raised to power 23. Okay. And this will be equals to what? This will be equals to 3.011 times 10 raised to power 23. So the correct answer is A. Okay. Question number two. The molar mass of a substance is defined as A, the mass of one molecule of the substance. This is not correct because one molecule of a substance, you may not even be able to measure it because that is the basic unit of that substance. Okay. The mass of, so this is not correct. The mass of 6.022 times 10 raised to the power 23 molecules. We know that 6.022 times 10 raised to the power 23 molecules means 1 mole of this particular substance, right? So, meaning that we can rephrase this statement as the mass of 6. The mass of 1 mole of the substance, which is correct. The sum of the atomic numbers of the elements in the compound, this is not correct. And the ratio of the compound's mass to its volume, this is not correct. This will likely be the density of that substance. Okay, so the correct answer is B. Next question. How many molecules are present in 8 gram of water? How many molecules are present in 8 gram of water? We are given the mass of a particular compound. So they ask us to calculate the number of molecules. And we know in this case, we have to use Avogadro's constant. So if we want to know the number of molecules, we know that will be equals to the mole times Avogadro's constant, 6.022 times 10 raised to power 23, right? So meaning that we need to know the mole of 18 gram of water. And mole is equals to mole represented by N is equals to mass over molar mass. And the mass of the water given is 18 gram, and the molar mass of water is 2 plus 16, okay, which is 18. So this is equals to 1, right? So the final answer will be the mole times the Avogadro's constant, right? Times 10 raised to power 23. Okay. This constant you'll be given in the exam if you ask this type of question. So you may not need to memorize it, but I'm sure if you go through together with me through this lesson, you will likely be able to commit it to memory. So the final answer will be equals to 6.022 times 10 raised to power 23. Okay, so the answer is A. Okay, next question. Which statement is correct about 22.4 liters of any ideal gas at standard temperature and pressure? Remember the ideal gas equation, PV is equals to nRT, from where we derived that at standard temperature and pressure, 1 mole of a gas occupy 22.4 liters. Okay, so which statement is correct about 22.4 liters of any ideal gas? We know that is 1 mole of that particular gas already. Okay, so let's go through the options. A contains the same number of molecules as 1 mole of oxygen. Yes, that is correct because 1 mole of any gas contain occupy 22.4 liter at standard temperature and pressure. That is correct. Contain 2 moles of the gas is not correct. Its mass is equal to 22.4 gram. No, that's not correct. Occupies the same volume of all gases. No, that's not correct. So the correct answer is A. Next question, they said calculate the volume of 2.5 moles of carbon dioxide gas. I believe we can do this right. So from the ideal gas equation that we talked about earlier, which is PV is equals to nRT. Okay, so you'll be able to calculate the volume. You can do the calculation and write your answer in the comment section below. Let's discuss. Question number 6. How many grams of sodium chloride are required to prepare 250 ml of 1 molar solution? So what you're going to use here is the concentration concent- concentration is equals to mole over volume. Okay, so we are given the concentration, but this concentration we said is equivalent to 1 mole per liter, right? And which is also equivalent to 1 mole over 1000 mil. It's very important for you to convert it to mil because the volume with which we'll be working is in mils. Okay, so this is our concentration. Let's replace it in this equation, and that will be 1 over 1000 is equals to the mole, which is which is mass over molar mass. Okay, divided by the volume, which is 250 mil. 250 mils. Okay, so if we bring this one here, it will be 1 over 1000 times 250, which is equals to mass over molar mass. Okay, and we know that the molar mass of sodium chloride is 23 plus 35.5, which is equals to 58.5, right? So if we substitute it in this equation to be 1, this will be here 4, here 1, right? So is 1 over 4 times 58.5, right? Which is the molar mass of the sodium chloride. So that will be equals to the mass. So if you divide this, here 1, here 1, then in 18, that will be 4 point. You can use your calculator. So I think this is the likely answer. The correct answer is A. If it's not the answer, you can comment in the section below. Let's have a discussion. I will leave the remaining question for you to solve. Go through them, okay? As I'm scrolling, you can pause, read the question very well, understand it, and answer it, and write your answer in the comment section below. Let's open up discussion. If you enjoyed this video, like it, share it for others to benefit, and subscribe. And also put on your alerts so that when I upload new videos, you will be notified on time. I think there is problem with this question. This is a repetition. I'm sorry about that. Okay, if E is equals to nRT. Okay, so go through the question, answer them, and comment your answer in the section below. Okay, so thank you very much. I wish you the best. Watch out for my next video. Like, share, and subscribe. Bye bye.